CCS Catalog Breakdown, Part 1, Area Scan. Today we're going to be focusing on area scan lights. In future webinars, we'll do the line scan lights and the controllers, so stay tuned for those if you're interested in learning about how those products break down as well. In the meantime, we'll talk about the catalog and just kind of how daunting it is. It's a very thick catalog, and if you're not familiar with our products and how our products work, it might seem like it's hard to know which option is best for your application. So my goal for the webinar today is to highlight the information that you can gather from the catalog to make the best choice for your application, so you can feel more confident with your choices and with what you pick. In order to do that, I'm going to talk about the product pages. I'm going to highlight that important information and talk about how to read the graphs that are provided. I'll talk about the product types, which series are our go-to, which ones are for more niche purposes. I'll talk about other pages, which are products that we have that don't necessarily have their own dedicated product page. And then I'll go through an example of choosing the right product and how I use the catalog to make that choice. And then some catalog tips and tricks that should help solving your application a little bit easier. So on to the product pages and gathering the important information. So your product page is going to look like this. At the top here is going to be the direction of the light. Then you have the type of the light, the series name. There'll be a picture of the product and a picture of the lineup. You'll have some section where it talks about unique features of the light or kind of how the light is built. What I want to focus on is this example configuration here. So this shows how the light was designed to work with the camera. So for this example here, this ring light, it was designed to be in line with the camera looking through that hole right here. If in this picture, the light is placed close to the sample, that indicates that the light working distance is meant to be shorter. And if it's placed further away, like in this example here, then it has less critical light working distance and can be placed kind of anywhere within the working distance of the camera. So if you're doing testing and you decide that the light solves your application best, if it's a ring light placed at 30 degrees, then place your ring light at 30 degrees when you're solving your sample. Do whatever testing solves. This is just meant to be a reference on where to start and to show you how the light was designed. So next on the product pages, there'll usually be some type of imaging example and using this light on an actual sample. What I want to talk about here, though, is the relative irradiance graph and the uniformity. So starting with the relative irradiance graph, this is not showing what the lux of the light is. This is showing the light in terms of its relative to its brightest point. So in this example here, the light is at 100% intensity at 40 millimeters light working distance. And that means that that is the peak light working distance for this light where you'll get the most intensity. As you move closer to the sample or further away, the intensity of the light drops down. And not every light will have this same shape and will have this same peak light working distance. A lot of them will just be brighter the closer you are to the sample and decrease as you move further away. So now that we kind of know what this graph is saying, how do we use it to pick a light? If my light working distance, for example, is 150 millimeters, I will know that this LDR250 RD2 is not going to be sufficient. It's not going to provide enough light for my application. I'll know I need to find something else. But if my light working distance is around 50 millimeters, I'll know that this is likely plenty of light and I don't have to worry about it. That being said, just because if you look at this and your light working distance happens to be somewhere around maybe 40 millimeter or 40%, for example, that does not necessarily mean that it won't be enough light for your application. It just means that it's 40% compared to the light's brightest point. But these lights and these LEDs are so bright these days that oftentimes that's still sufficient amount of light to solve your application. If you are getting to 150 millimeters, like I said, and you're at more 10%, 20%, it would be worth exploring a more intense light like a type of dedicated strobe. But that would be how you use this irradiance graph to know, am I going to get enough light probably yes or no. Next, we can move on to the uniformity. So this shows what the light looks like as it's shining onto a flat surface. So you can see that the red is going to be the brightest, 100% intensity. The yellow color is 50% intensity, and the blue is 0% intensity. So when I'm looking at this, 9 squares of 5 millimeters, so a 45 millimeter square field of view, I can tell that this light is not going to provide uniformity in this whole field of view. Its best uniformity is going to be probably 20 by 20 millimeters, maybe a little bit more if you're okay with a little bit darker edging on the corners. But at, 30 millimeters, we're at 50% intensity here. So I can use this information to say, okay, my field of view is 30 millimeters and my light working distance is around 50. Will this provide an even illumination? And you can kind of infer that no, it won't. I either need to step up to a larger light or increase my light working distance, but optimize that with the intensity of the light. If I increase my light working distance, will I have enough light? So using these two pieces of information together, you can kind of get a good idea of, will this size light work for my application? Or kind of you can even take it a step further and think, okay, if 50 works this big on 45 millimeter field of view and my field of view is 100 millimeters, I need at least 100 millimeter or 150 millimeter size light. So you can use it as a ratio in a way, but it just gives you a good idea of what your light will look like as it shines onto a flat surface for you to make, informed decisions on your own application. The next portion that the product pages will have is usually a custom order. So for example, here you can get a half ring light designed. So these would be not standard products, but custom orders that we make enough that we do them really easily and really well. Otherwise, if it doesn't have custom order information, they'll have more features, comparison data to old series or something like that. Next is the lineup. So to zoom in on the lineup here, you have your classification. Is it a standard product? Is it a technically custom order product, or maybe more made to order product? And then it has the model name. It has the input voltage. Most of our lights are going to be 24 volts. If it doesn't say 24 volts right here, that means the light is current driven. And you would need a special controller for that. The next information you can gather is the color of the light and what the power consumption of that light is. And then it has options available. So if it has a optional diffuser plate or optional polarizer plate, that would be listed right here, what can go with that specific light. And then next is the extension cables. So this is the FCB series, works with the light. And then you can have different, branch cables or robotics cables, something like that. And then there is the recommended controller units. So this just tells you the series of controllers that works with this light. Once you pick the series, you would go to that series product page in the catalog and then pick the specific model. And you would use the power consumption of each light, the number of lights you have, to know which controller you need for all of your lights. And when I said, the current driven lights would need a special controller, that would be indicated in the recommended controller unit. So it would have specific controllers that work with current driven lights. These are controllers that work with voltage driven lights. And just kind of one thing to highlight kind of how to read this. So the CCS 1024, this is listed as an option up until the LDR 270. It's not listed as an option for the LDR 290, and that's because the max power consumption for this controller is 10 watts, and the LDR 290 is 11 watts. So this light and higher is not rated for this controller. So that's why it's only listed in the front half of this list. So that's how you can read the lineup and kind of make sure you're getting the right information. Pretty much we want to know the power consumption of each light and the controllers that work with it. So next, there is the LED properties. So this is the spectrum distribution. It's going to tell you the peak wavelength of the LEDs that are in this series. But the maybe arguably more important information is the directional characteristics here. And this is similar information to the irradiance graph that was provided, where it's not giving any lux information, but it is showing the light, where the light is at its brightest point, brightest intensity, or 100% irradiance. So you can see here if the light is facing on a table and shining straight up, we put a meter measuring the irradiance of the light. So when the meter is perpendicular to the light, that's where we're at our brightest point, or 100% of the light's intensity. And as we move further away, 20, as we angle the meter around the light, is probably a better way to say it, get to 20, 30, 40% of an angle, or 40 degrees of an angle, our relative irradiance drops down. So we're at 100% intensity. At 20 degrees, we're at 80% intensity. At 40 degrees, we're at, maybe 60%, 50% intensity. So you can tell that the illuminating angle of this LED, this white LED, is fairly narrow, especially if you compare it to the red wide type LED, where at 20 degrees we're still at 90% intensity, and at 45 degrees we're still at about 80% intensity. So the angle of this LED is much wider than the angle of the white and the red and the blue. So what we can take away from this is just essentially, do we want the wide type or not? The wide type would be good if we've got, we need a uniformity in a larger field of view, for example, or we're going to be further away, or closer even, versus if you need a narrow type if your field of view is smaller, something like that. So this just tells you the illuminating, or the emitting angle is of each LED in this scenario. Next on the product pages is going to be options. So this will be the same things that were listed in the lineup, but just a little bit more detail here, essentially giving you the exact model name for the light that the series offers. And after the options is going to be the dimensions of each light. In this situation, it gives the outer diameter, the inner diameter, and the thickness. So that is pretty much the important information for the, standard information for a lot of the product pages. Now getting on to the product types. The catalog is broken down into categories. There's, ring, square, bar, flat, dome, etc. I'm going to be talking about everything up until spotlight, and then other products and options. So these other categories will be in future webinars. So to get started on ring lights, we have a few different kinds. We have direct ring lights, multi-angle ring lights, and flood ring lights. I'll get into kind of the go-tos and touch a little bit on, the older technology that we don't necessarily recommend. So on the pages like this, anything that's bolded means these are our go-to recommendations. There's little asterisks here with FE ring. FE ring and FE Lux lights are in our catalog, but since they're FE Lux products, they don't necessarily have their own product page. So I'm not going to go through them the same way I'm going through the CCS lights. I will touch on it a little bit later on, the FE Lux products, and get more specific, but that's just kind of the caveat with the FE Lux lights. I'll still mention when we would use them in which scenarios as well, though. So for the direct ring lights, our go-to is the LDR2 series, which it's got a high direction and it's considered a direct light. The applications are, character recognition. It's your standard bar ring light applications, looking at damages, stains, visual inspections of any kind. And then the low angle version of that light is the LDR2LA and the LDR-LA1. So the difference between these two lights is the LA version has 3 rows of LEDs that are at a pretty good angle, but not a 0-degree angle like the LA1. So the purpose of using this light is it's a low angle light, but it still has intensity in those 3 rows of LEDs and a little bit higher, a little bit more illumination. So you can kind of see more of the top of the surface, versus the LA1 is that 0-degree light, it's got one LED that is parallel with the sample. And so you have a very, very low angle effect here. So it's really great for fine scratches or engraved text, edge extraction, stuff like that. So the difference between these two is hard to say a hard and fast rule. Oftentimes, most of the time, it comes down to testing. Sometimes I expect this one to work and this is the best image, and vice versa. So if you have scratches, engraved text, metal, something like that, try a low angle light. Try each one of these to see which one works best. So the SQR and the SQR-TP, these are kind of the low cost versions of the LDR2. They have a time and place, but they're not necessarily our go-to that we would recommend very often. Next is the multi-angle ring lights, and pretty much our only go-to for that is the HPR2. It's got a light guiding diffusion plate with an LED that shines down, so at a short working distance it works like a low angle, and a longer working distance it works more like a standard ring light. I am a big fan of this light when I do testing, so it's always great to have one of these on hand. Another unique thing about this is it has full color versions available as a standard option. So the LED would have a red, green, and blue LED, and you can turn on any one of those colors or all of the above to get whatever combination you need to solve your light or do your lab testing. Earlier versions of ring lights that we have are the FPR, the LFR, and the LKR. Here's kind of the difference between each one. They're all a little bit older technology that we don't really use as a go-to anymore. And the reason why they're still in our catalog and still listed as options is because most of our lights at one point were developed as a custom solution for a customer in the past, and then eventually became standardized into their own series. So a lot of these products still exist because they're for that customer who we're still serving and who's still using this product. So that's why it's still in the catalog and still around, even if it's not our current go-to product that we recommend. So next is flood ring lights, and our go-to for this is going to be the HLDR3 and the FE Lux FE ring. This graph right here is just another way to look at that directional characteristic graph of the angle of the light and then the relative intensity of it. So the wide type has more intensity at a wider angle, so you can tell it's a wide type. In terms of when to pick the FE Lux FE ring versus the HLDR3, they have very similar results. They have similar intensity, both great products. The FE ring is a little bit more of a cost-effective solution, so we recommend that more often than not for kind of that reason. But I think the narrow type of the HLDR is more intense than the FE Lux, so sometimes if it's a long working distance, we'll factor in which one has the brightest intensity from whatever distance you're working at. But they're both great lights, and they both have a good results for your application if you're looking for large field of view or large light working distances. Next up is bar lights. So we have direct bar lights and flood bar lights. The go-to for the direct bar lights are the LDL2. These have a lot of LEDs. They're backlit bar lights, and they shine down onto a sample. They're very flexible in terms of how all bar lights are. They can be mounted at a low angle. They can be mounted more straight down for uniformity. They solve a large variety of applications. The LB light is essentially an overlap between a bar light, like an LDL2, and a backlight, where it's designed like a backlight, where you have backlit LEDs shining onto a really diffuse diffuser and providing a very uniform illumination, but kind of more similar to the shape of a bar light than a backlight. So they can be used to have good uniformity on reflective surfaces, especially if they're a little bit larger, or just providing a good even uniformity on nearly any surface and having a lot of different ways they can be configured. So when to pick each one of these, I would say the LDL2 is great for high precision, maybe smaller field of view applications, and then the LB is where you need maybe a little bit more uniformity, maybe more reflective surfaces, or maybe like slightly larger field of view than the LDL2. And then for flood bar lights, again, our go-to is HLDL3 and the FE Flex 2 from FElux. And this is kind of going to be the same vibe as the flood ring lights, where they both are great products. They both work in similar ways to each other. FE Flex 2 is a little bit more of a cost-effective solution, so we tend to recommend that one more often, but they both have a time and place, and if you're not sure which one to do from the LDL or HLDL3 to the FE Flex 2, feel free to give us a call and we can add our input based on our experience, but they both work very similar to each other. On to flat lights. We have a lot of different kinds of flat lights. There's the backlit backlight, the edge-lit backlight, a collimated backlight, and a flood backlight. Flood backlight doesn't make a lot of sense. Not really too many people refer to them that way, but I did it for the sake of consistency, because that's how I referred to the other large area lights that I've been talking about. So essentially just the large area illumination is what I mean for as a flood backlight. So our go-to for the backlit flat light is the TH2. So it's designed with all the LEDs are on the back of the light. They shine up into a really diffuse diffusion plate, and then that illuminates a very uniform emitting surface to the camera. So applications for backlights are, liquid surface level, appearance of pinholes, scratches on clear metals, burr of metal components, stuff like that. And this is the LB is also a good go-to. The difference between these two is pretty much a little bit of thickness, but mostly the shape and that they come in. And they have the same applications because they're very similar light in terms of backlight shining up into a diffuse plate going up into the camera. The LFL is an edge-lit backlight, so it's kind of more of a niche use because it's extremely thin, but it's not uniform. Essentially, the lights are they're in the light shining, instead of straight up to the camera, they shine from the side into the light that has a very reflective coating that kind of directs the light up. So for that reason, they're very bright along the edges and pretty dim in the middle. The only time we would really ever recommend them is if space was a huge problem and uniformity wasn't really that critical. We also recommend the FE Flux FE backlight. That's kind of the flood backlight large field of view applications. It does not have to only be for large field of view applications. It can also be a go-to for kind of any standard backlight. The FE Flux backlight is also a backlit backlight shining into a thick diffuser. The difference between the FE Lux backlight is the thickness. That one's a lot thicker than the TH2. So sometimes the space can be a problem with this backlight. For a collimated backlight, our go-to is the TH2 PM and then the TH2 with light control film. So the TH2 PM is essentially the TH2 backlight with a prism sheet built into it. And then the TH2 with light control film is essentially you're purchasing two separate things. You would purchase the TH2 and then you would purchase the two different light control films along with that. The point of collimation, if you're interested in that, we have a lot of webinars that talk about using collimated light to solve our applications. It just gives very sharp edges by collimating the light. Using the prism sheet and the light control film isn't a true optically collimated light like the MFU is, where the MFU uses optics to make the light super parallel instead of just kind of blocking it off or directing it like these two options do. The MFU is a really small field of view, so it's definitely more of a niche use. The difference between the TH2 PM and the TH2 plus light control film, the prism sheet is a little bit brighter. You don't necessarily lose or block as much light versus the TH2 with the light control film, especially if you're using the horizontal and the vertical together, it's a lot darker. So kind of in line with that, the light control film, there are two different sheets that you need to purchase. So there'll be one that blocks the light in the horizontal direction and the one that blocks it in the vertical direction. Some applications have the best results when they are just using one. You're either blocking the only horizontal or blocking the vertical. But to get the same results as the TH2PM, you would have to use both of these together. So that's kind of the difference between these two products. You'll get similar results, other than this one will be a little bit darker because you're blocking more light. So now on to dome lights. So we have standard dome lights, flat dome lights, and perfect dome lights. So a standard dome light is going to be where you have that big shell, the LED shines up into a reflective panel, and then it's very diffuse and even light shining down onto your sample. The best part of dome lights is they work really well on curved surfaces or rounded surfaces, stuff like that, but they remove texture really well. So if you're trying to hide a lot of texture or bumps or something like that in your sample, and you just want to, for example, read a text, a dome light's going to be a good go-to for that. Earlier versions of this, the LDM2 that's in the catalog, it's just kind of older technology. We go with the HPD2 now. Some more niche uses are the perfect dome light. It's called the PDM. The LAV is the older version of it. It's a coaxial dome and a low angle light. We essentially moved on from this. The technology of the dome light has kind of been improved with the HPD2. So now we recommend getting the dome light. We sell a bracket and a coaxial light that goes with it. So if you're using the HPD2 100, you would buy the LFV 350 and then the HPD2 100 LFV bracket, and that goes together. And the point of that is, on some really reflective samples, that camera hole that the dome light has for the camera to look through can cause a dark circle in the really reflective sample. So if you put a coaxial light there, you're essentially illuminating light through that dark circle and removing the dark circle. And this just holds it all together in a nice, unique way. So these are kind of superseded by the light and bracket, and you get better results using this than you would with the PDM. For flat dome lights, we have a few go-tos. There's two different kinds of flat dome lights. So there's LFXV, LFX3, which is a shadowless light in a thin profile. So it's got LEDs that shine from the side into a light guiding acrylic plate that direct the light down in a really diffuse way. The closer that this light is to the sample, the more of a dome light effect you have. And as you move further away, you kind of change the collimation. So it's really honestly a pretty cool light. But this camera is looking through that light guiding plate, so you don't have that same camera hole problem that the dome light has. Versus the TH2CR is essentially a backlight, but it's got a camera window for the camera to look down. So this is going to be a little bit less diffuse than the TH2 or a dome light, maybe a little bit more direct characteristics. But it can be made a lot larger because you're utilizing backlit technology and you don't have the shell that gets really big as you do with the standard dome light. We also recommend the FE flat dome, which is very similar to the TH2, where it's the FE backlight with a camera hole in it. That can be very large, so it's also great for floodlight applications, but can be used for smaller applications as well. This one is thicker, so if space is a problem, then it isn't ideal, but otherwise they're very similar in results, the TH2CR and the FE Lux, FE flat dome. Next is coaxial lights. So we have kind of two different coaxial lights. There's standard coaxial lights and collimated coaxial lights. So the way a coaxial light is designed is the light shines through, it hits a half mirror. The light is reflected down onto the sample, reflected off the sample, and up through into the camera. Within the LFV3, there are a few different versions, a few different models. So there's the standard LFV3, which uses a half mirror, and that's going to be good for 80%, 90% of the applications that we kind of come across, where it's a standard 5 megapixel camera, standard field of view. You're not doing too much. You just need the right illumination to see the scratch. If you are having applications where you have a stronger resolution, maybe a smaller field of view, and you're getting kind of this ghosting effect where it looks like it's blurry, that has to do with the thickness of the half mirror. There is a description of that in the catalog if you're interested in learning more. But to solve that problem, we have the LFV3G, and that just has a slimmer half mirror to give you more clarity and not have that ghosting problem. For very small and high resolution applications, we have the LFV3CP, and this actually uses a beam splitter instead of a half mirror. So you have really a lot of clarity and high resolution and a small field of view. The kind of niche use, the MSU, is a highly collimated, this is actually an optically collimated coaxial light, similar to the MFU for the backlight. And the reason it's niche is it just has a really small field of view, and oftentimes people don't need this level of collimation to solve their application. So that's kind of the difference between these three products and when you would use each model in which scenario. So next we have spotlights. The breakdown, there's kind of our standard spotlights with the microfiber head, and then high power light sources with light guides. Our go-to spotlight is the HLV3. It's got two different shapes. There's the cylindrical shape and the L shape, and your kind of standard high output uniform spotlight. There is options to add a condenser lens to it to change the the distance that it's illuminated and the diameter of the illuminated spot. And then the LV is just kind of the earlier version of the HLV3. The other options are spotlights with a microfiber head. So that's where you would take essentially this microfiber head, it's ring light or extended spotlight, and connect it to one of our spotlights. Or you can connect it to this little box here, which would be like an RGB version. So you would have a red, green, and blue spotlight, and you could turn on each one of those to illuminate whatever color you need for whatever situation you're in. So next after this, there's kind of series where there's just one light in the series or type, and then different wavelength specific series that the catalog has. So I'll talk about square lights, strobe lights, UV, infrared, reference light sources, and then the IU series. So for square lights, we have the FPQ3. This is works kind of similar to the HPR2 in a way. It's got a light guide diffusion plate. It can work at a short light working distance as a low angle light, but it has this reflection plate that you can add as an option to kind of give it more of a dome light effect. So here there's some pinholes that we couldn't see without the reflection plate, but with it we can read the code and see the pinholes. Since it's the only one, it's a good go-to. It works really well for square pieces, a lot of semiconductor electronic components, stuff like that. Next, we have dedicated strobe lights. So this is for applications that have a very, very high exposure time. You can see here in this example in the catalog, it's got 4 microsecond exposure time. So these are made to flash extremely bright for extremely short pulses. There's a big kind of variety of the lineup. You can do ring lights, low angle ring, the FPQ, bar lights, backlights, dome, coaxial, and flat dome lights. We also have the FE Flex LG light, which is their version of a strobe bar light. So these two, it's the bar light of the PF series and the bar light of the FE Flex LG light. Again, similar results to each other. When we recommend one over the other, if it's just a standard bar light, we would probably recommend the Flex LG. If you need to have specifically a coaxial light, but you need it to be really intense, then we would say, okay, then you need the PF series, LFV PF series. So both are extremely useful if you have high speed applications. Definitely recommend trying them out. Next, for wavelength, we have the non-visible wavelengths, the UV3. So there's the UV3 and UVVL3, which is ultraviolet visible light, and then 3 is just the third generation. So applications are, your standard UV applications, reveal invisible ink. The wavelengths that are coding, stuff like that. Wavelengths that are available are 365, 385, 395, and 405 nanometers. They come in a lot of form factors, but the reason for keeping UV in the catalog and not just going with the UV3 is the UV has more form factors than the UV3. So if there's a specific form factor that you are looking for that you don't see in the UV3, check out the UV section. It might have it. One thing to note though is the UV3 is going to be more intense than the UV, so you have to factor that in as well. And then the LNSP UV3, those are for line scan applications. So next, moving on to the IR2 non-visible wavelength lights. The IR2 and IR light works where it can penetrate through certain materials and reflect off others. So in this example, we're penetrating through the print, and so we're able to reveal a pinhole. The form factor, the designated form factor, there's ring lights, coaxials, flats, and the wavelengths are going to be 850, some 857, 860, 940, 950. The difference between 850 and 860 is not going to be that different. So, I think our LFXV is 850, but our HPR2 is 860, something like that, or LDR2, I'm sorry, is 860, but that's not really going to matter. Same with 940 to 950. I would say having one 850 and one 940 in a lab is useful. When it comes to IR2 versus IR, the IR is the legacy product. And one thing to note about this series is there are other lights that are offered in IR that aren't in this section of the catalog. And the reason for that is when these lights are being developed, UV and IR were not an option in terms of the LEDs weren't available. And then when they finally did become available, we made a dedicated series. But as we've renewed, the HLDR2 and the HPR2, HLDR-L3, we've added the IR lights to that lineup. So that's why there's a section, a dedicated IR series in the catalog, but also certain products have their own IR lights as well. So if you have a certain product that you do want as IR and you're not seeing it in the IR section, then double check that see if it's available in the actual, HPR2 series light. Next is the CIR. So this is not an LED, this is a halogen light. And the point of this light is the spectral distribution goes very long. It goes all the way out to 2400 nanometers. Most IR lights stop at 940, so 1000. SWIR lights go up to about 1650. And this light goes even further than that. So the point of this is for hyperspectral and SWIR cameras to take specific imaging. So for this light, you don't need it unless you know you need it. So if you're just trying to solve your general applications, this light shouldn't be on your radar at all. But if you're doing hyperspectral imaging, then by all means, take a look at it. It's a pretty cool technology. Next is the reference light source. So this is essentially a light just made for calibrating cameras, your gain, your white balance, stuff like that. Backlight for chart imaging inspections. We don't come across this too often, but it does exist if it is something that you need. If you're just doing your general vision applications, this probably isn't going to be a requirement for you to have or to test with. Next is the intensity control, or the IU series. So this series is cool because it actually has the ability to adjust the intensity and the on-off of the control of the light without an external controller. So this knob here, you would push, the plus sign for more intensity and then minus sign for less intensity. And then it has an M12 input to connect to a smart camera. It comes in only red and white colors and in these lineups, this series. So if you are, you want just a quick connect to a smart camera with a little bit of intensity control, the IU series is definitely something to consider. But in terms of how it functions compared to like the HPR2 standard light, they're going to be the same. It just is the control in this cable is the only difference. Okay, so that's the end of the products and kind of our go-tos, what's niche and what's not, what you need to, reference and what you can kind of ignore in terms of series. So now I'll talk about the other pages and options that come up. So for other pages, we have the iTech products. So I'm only touching on this because it's part of the other pages, but technically they're line scan cameras. So there is the tunnel dome, where it's a dome light before a line scan camera. And then the other one is the LNGA, LNHA, which is the extremely high output line light. So there's a 1.2 million lux version and a 2.8 million lux version. So this is CCS sells it, but we worked with iTech as iTech Light to they have it, they developed it. Next is the Basler camera light products. This is another page. So this is essentially intelligent lighting and easy integration. So what this does is the Basler Pylon software can control the light, the settings of the light within the Pylon software. So you just have to use a specific light that has this BCL specific light, and then you can use the Pylon software to set your trigger, set your intensity, set your exposure time. Anything you need can just be done here. So it kind of removes the need of a controller, but you still get a lot of the control. There's also a Basler SLP, which is the controller. So if the SPL light or the BCL light, I'm sorry, doesn't work with the size that you need or something like that, but you still want to use this technology, then you could use the Basler SLP controller for any light to do the same features, where you can have the Pylon software control the light and work directly with the camera. Up next in the catalog is the Optex FA, their fastest line. So this essentially is a controller lighting combo that does a lot of sensing and feedback for really specific applications. Essentially, it can say lights will fluctuate very slightly, and for most applications that's fine and negligible, nobody even notices. But every once in a while there's an application where they can have zero fluctuation. So this software can fluctuation due to temperature changes. It can give feedback on if the light has dropped in intensity for too much. It can maintain consistent level of brightness, where it'll say the light has dropped, but it will increase the intensity. So for the images, it stays the same. There's just a lot of monitoring that this process does. And kind of like I said a little bit earlier, most applications don't need this level of monitoring and feedback. And if you don't think you need it, then you don't need it. If you know you need it, then it's good for that reason. But most of the time, people don't need this level of monitoring, this level of feedback. Next is the computational imaging. So this is essentially the idea of taking multiple images and combining them into one. There are a bunch of different techniques that you can do. There's a high resolution color image, bright field, dark field, photometric stereo. That's where you get the texture image and the shape image to see those 3D height changes. You can do extended depth of field images, and then the HDR, where you're taking different intensity levels and then taking the best of each image of the intensity level. That's pretty much, there's a few different ways that we can do it, and this portion of the catalog kind of talks about how we can. So next is FE-Lux, which I've touched on throughout the presentation of being, flood lighting and options that we have. We have this 3-ring logo here because CCS is sister companies with FE-Lux and Gardasoft, where we sell FE-Lux products, we sell Gardasoft products, and then we sell our own products as well. So if you want to buy a Gardasoft controller, you can still buy it, and you do buy it through CCS. And if you want to buy an FE-Lux controller, you buy it through CCS. For FE-Lux, the kind of purpose of these lights, they are high quality plug and play lighting. They have M12 connections, so they can connect directly to a smart camera. They have built-in drivers where they will auto strobe, so they'll be overdriving for the first initial few hundred milliseconds, and then, or few hundred microseconds or 2 milliseconds, and then go down to continuous use. They also have the ability to open up the open up the light and you can adjust the lens to change the emitting angle, or you can adjust the window to optimize your uniformity versus your intensity. They're honestly very useful, very flexible lights. We use them very frequently, so just because they're not featured in our catalog like a product page doesn't mean they're not extremely useful to us. If you have questions about them, please reach out. We also have a portion of the pages that's Gardasoft. So these are current driven controllers for machine vision lighting. So they've got, constant current lighting controllers versus CCS's controllers are voltage. There's sequencing controllers, lensing controllers. In this portion of the catalog, there's a selection guide for all the Gardasoft controllers, and then it talks about their Trinity technology as well. There's also a control unit selection guide where it goes through how to find a power supply based on certain parameters. If you're looking by, what type of external control, or if you're looking by capacity, if you need a large light, which controller series will do that. So this is just a good guide on helping you choose the right controller for your application. Next is the options. So this is kind of already listed in the product pages, but the options portion in the back of the catalog just goes a little bit more in depth. So it goes through lens filters, the diffusion plates that are available, polarizing plates like control film, fixtures, brackets, cables. One thing to kind of note is, so you'll pick the product that you have, and then this will be the model name that you need to go with. Some products have a horizontal and a vertical distinction. So for polarizers, if you don't have -VE at the end, you're just getting the standard polarizer. But for some bar lights, you do want to have a vertical and a horizontal polarizer. And so this would be where you would add -VE to the end of your part number to get the horizontal and the vertical versions. Kind of the same thing for the light control film that I mentioned. There's a horizontal and vertical direction to that as well. So you would have to have these two part numbers to get the light control film for your backlight. The cables, you have the cable pages for the SM and the EL cables, and these are just kind of the difference between what each one is. There's straight, and then there's 2 and 4 branch cables and a robotics cable. The robotics cable is meant to be flexible and have more durability, so if you're going to use a robot or have the light moving around a lot, we would recommend going with the robot cable in that regard. If you do go with a branch cable, one thing to note is the intensity for one is the intensity for all. So if you do plan to have 2 lights connected to one channel on a controller, whatever that channel intensity is set to will be the intensity for both lights. If you need them to have different intensities, make sure you have at least a 2-channel controller so you can control the intensity of each one separately. So now on to choosing the right product. So how to navigate. If I am doing testing and I have an application that comes up, and with my own just experience, I know that a dome light is going to be what I need, but I'm not 100% sure which kind of dome light or exactly which dome light from the catalog or from CCS's product lineup is great. I can kind of think of it in terms of the series, the wavelength, and the size. So thinking about the series to start, I know that there are 3 types of dome lights. There's the traditional dome, the flat dome, and the panel. Of the traditional dome lights, I can ignore the LDM2, LAV, and PDM. Of the flat dome, there's LFXV and the LFX3. The LFXV has a smaller dot pattern effect and more intensity, but the LFX3 doesn't have the cloudy effect that the V can have. These are going to be the same in terms of how they, function with the light working distance. The only difference is that dot pattern effect. Most of the time, the cloudy effect is not a problem, but sometimes the smaller dot pattern effect can be a big benefit, so I would lean towards the LFXV. And then a panel light, there's the FE flat dome or the TH2CR. The FE flat dome's a lower cost, but a little bit thicker, so depending on how much space I have is how much I could get away with there as well. So once I can kind of go through each parameters of how to choose each one of these lights, I can pick my series. Then you can pick the color. Light colors will lighten and opposite colors will darken. So a red light will lighten anything red or yellow, but will darken anything blue. If I want to remove color, I can go with IR light. If I have a product that has a lot of color variation in it from sample to sample, then I would want to go with a white light so I'm not causing problems with light samples, even though it works on dark samples. And then in the end, always test the wavelength and the series. And the size, general rule of thumb for a flat dome light or for any dome light is the field of view times 2 should be the size of the light. This is a flexible rule. It depends on the surface of the sample, the light working distance, lots of factors. So anywhere from 1.5 to 2 times the size is going to be good, but you should test both just to make sure. So just knowing I need a dome light, I can rule out, from 6 different types to maybe 1 or 2. I can get a good idea of the color based on what the color of my sample is, and a good idea of the size based on your general rule of thumb. But let's say I want to get a little bit more specific. In this example, let's say I have a dome light that's needed, a field of view of 120 millimeters, and a working distance of 50 millimeters. I can use the information from the catalog of the relative irradiance graph and the uniformity to get a good idea of if it will work or not. So I can see here that in the corners, even at any light working distance, there's going to be dark corners based on just this uniformity graph. At the light working distance of 40 millimeters, I get pretty good drop off here at the corner. So at a light working distance of 50 millimeters, I know I'm going to get even more drop off. And I can tell that at a light working distance of 50 millimeters, my relative irradiance is at 80%. So it's going to be bright enough, but my uniformity might be a challenge. So based on looking at what 120 millimeter field of view looks like with this uniformity of a 200 millimeter light, I would probably want to step up to 300 millimeter or 400 millimeter light to get better results. So next is going to be tips and tricks in the catalog. So after the option section, there's going to be the control unit selection guide, examples of custom ordered products, examples of applications, different types of applications, some information on UV keying, natural white LEDs for like high color rendering index. There's the index, the model index, and discontinued products. And then we get into the technical guide. And the technical guide is where I think there's underutilized information. The first one that's underutilized is the effective field of view of coaxial lights. So there is a whole section where it tells you how to calculate the field of view of your coaxial light based on the size of light, the light working distance that you have, things like that. So if you're interested or working with coaxial light, not sure what to go with, there's a whole portion of the catalog that can help you make that choice. Next is going to be the comparison of different light types on the same application. I think that this is a really useful page because it takes the same 4 applications and a variety of lights and kind of shows you how each one images. So if your application is, similar to this metal workpiece, you can look and see, oh, flat dome gave me is a really good image for this. I can try that for my application. So it just does a good job of showing what each light does on different surfaces. Next is how to calculate pixel resolution and the line sensor camera. So this is calculating the pixel resolution and then basic line scan sensor information. We'll get into it more in the line scan webinar, I'm sure, but just testing line scan is not as easy as an area scan, and the resolution really matters for line scan applications. So it's really important to calculate first and then set the line scan camera and settings. So this will help you with those calculations and how to set that up if you're doing line scan applications. How to calculate the working distance. This again is just more calculations, talks about the ratio of finding the working distance and useful information. Do you have to do this calculation before solving your applications? No, you can definitely just put the light in and see which working distance solves your application. But it does help if you're just not really sure where to start. It's just useful knowledge to consider. And then there's other, field of view chart regulations, stuff like that involved in the catalog as well. But those were kind of the ones that I would highlight and encourage people to take a look at. But that being said, that is the end of the webinar. So if there's any questions, let's start now.